Hello everyone, welcome back to Cambridge Guru once again. As you know that we are doing chapter vectors, and last video we did some question about finding out the angle between any two given vectors. So next topic today we are going to cover is finding out the vector equation of a line. Right, so without wasting any time, let us start. So it says that if A and B are 2 points with position vectors A and B, then the equation R is equal to OA plus lambda times AB. It can be written as, so this is the general vector form of the equation of the line joining 2 points. Meaning is that let us say we have 2 points. Let us say this is our, let us say this is our coordinate system, and this is y-axis, this is z-axis, and in the space we have point A whose position vector is given by OA, and a point B whose position vector is given by OB. This is origin and this is your OB, right? And this is vector OA, this is vector OB, right? And if I join this point A, these points A and B, I get a vector AB like this. Okay, this is my vector AB. Now it says that vector equation of a line meaning is that if I extend this vector AB like this, okay, so if I extend this vector in the direction of AB, I will get a straight line. So just like in Cartesian system, we have equation of a straight line. Meaning of that equation of a straight line is that if there is any point of the type, let us say 1, 2, and there is a condition between x and y, there is a relation between x and y. So meaning of this, that equation of a straight line means any point either will satisfy, means we have to find out that whether a given point is lying on a straight line or not, and that we can find out by equating the LHS and RHS, right? Means a point should satisfy the condition. If I say that the equation of a line is x plus y is equal to 1, right? So this means that all the points which lie on this straight line will satisfy this condition. This is the meaning of finding out the equation of a straight line, right? So in the same way, for vector form of a equation of a line, meaning is that instead of points we have the position vector, right? So any position vector which will lie on this line, this extended line AB, right? Let us say that a point is C, okay? So any point which is lying on this straight line will satisfy this condition, which is OA plus lambda times AB. This is the meaning of vector equation of a line, and this point C can lie anywhere along this straight line, right? And finding out the equation means we are finding out the position vector of this point C which is lying along this straight line, right? Means if I join this O with C, so I will get the position vector, and that position vector is denoted by vector R. Okay, now let us take an example, or let us see how we have arrived this condition, right? This is just a deriving of this equation OA plus lambda times AB, and let us understand what you mean by this quantity lambda. Okay, this is very easy, because if you have understood the vector law of addition, triangular law of addition, right? So this vector equation of a line is basically based on triangular law of addition, that if we have to add two vectors, then tail will be joined by the tail of second vector will be joined by the tip of the first vector, right? So if this is my second vector AB and this is your first vector OA, so its tip means this point will join the tip of AB vector, you will get the vector OB, right? This is called triangular law of addition of any two vectors. So if I say that there is a point D which is lying somewhere between A and B, such that this point D is at the midpoint of AB. I'm repeating that this point D is midpoint of AB. That means if I say that this is your vector R, Okay, I join this O with D, and I am interested in finding out the vector R, position vector R, means OD we have to find out. Okay, OD we have to find out, denoting this vector by vector R. So according to the triangular law of addition, meaning is that OA plus AD is equal to OD, right? That means OA plus AD is OD, right? That means this vector R is equal to OA plus, now this AD vector is half of AB, because I said that this D is midpoint of AB, right? So if D is midpoint of AB, that means this is half of AB. So I will write this AD as just half of vector AB, because I have been given the information of just A and B, not this D. I do not know the vector. This we have to find out. Okay, so this vector R is OA plus half of AB, means position vector of a point which is lying at the midpoint of AB. So this will satisfy this condition. So I would say that this is the vector equation of this point D. Right, now if I change this point D, let us take another point which is, let us say, E. Okay, this point is E and it is lying such that it is 1/3 the distance of AB. Right, I will say that AE vector is 1/3 of AB. Right, just like AD vector was half of AB, this time AE is 1/3 of AB. Right, so now I have to find out this vector equation of this point E. Right, so this will be that vector R is, again I will start from O, reach to point A, and according to triangular law of addition, OA plus AE is OE. Right, so OA plus AE. So AE I will write as 1/3 of AB. Right, let us take another point F, which is this time lying outside this triangle OAB. Let us say this point is F. Okay, joining this O with F, I will get this vector. Right, and this time this F is twice of AB. Okay, just like we have AF vector as twice of AB vector. Right, so I will write this as that AF is twice of AB. So again, the position vector of this, or I will say that vector equation of OF, will be that vector R is OA plus twice of AF. Again, I am repeating that it is based just on triangular law of addition. Right, if I have to move from O to F, I will go from O to A and then from A to F, and writing AF in terms of AB, because I have been given the information of just of A and B, so this is twice of AB. Right, so now point is that if you look at this equation number 1, this is equation 2 and this is equation 3. If you look closely between equation 1, 2 and 3, what you will notice that this vector R is same, this OA vector is also same in all these three equations, though the points are different. And again, AB, this is AB, and this twice of AF, not this is AB. Okay, this is not AF. AF was twice of AB, right? So this ABs are also same in all the three equations. So only difference it is making about this quantity, which is the scalar quantity. In the first equation it is half, in the second it is 1/3, and in the third it is 2. Right, and this half, 1, 3 and 2, it is just indicating the position of the corresponding point relative to AB. Right, so this half is in the first phase, in the first case D was the point, right, so it is half of AB. In the second it was 1/3 of AB, point E, and in the third F point it is twice of AB. So relative to the position of, relative to this AB, position of F is given, and that is denoted by this scalar quantity half, 1/3 and 2. So in general, now I am on the verge of deriving the equation, which is that in general, if there is any point which is lying on this straight line, whether it is outside or inside, it is of the form vector R is equal to OA plus some scalar. I will multiply by the direction AB, right? Because you can see from 1, 2 and 3 that you are just multiplying AB vector by some constant or by some scalar quantity, right? So I am calling that scalar quantity lambda times AB. Okay, so this is your vector equation of a straight line, right? Now in this vector equation, there are two important vectors. As you have noticed here, that wherever I am going to the point which is lying on the straight line AB, I am starting from origin, then I am reaching to point A, and then I am following this direction AB. Again, I am repeating that first I am reaching the point A, and after reaching this point A, I can follow any direction. Either I can go like this, I can go like this, okay, any direction I can follow, but I have to follow one direction which is along AB to get the point which is lying along this line AB, right? So as you have in Cartesian system, you need two you can say information or two values to find out the equation. One is the coordinate and second is the gradient. In order to find out the Cartesian equation of a straight line, you need two things. One is gradient and second is point, right? Similarly, the counterpart of that is that the point corresponds to the position of this point A and gradient corresponds to the direction of A, that along which direction you are moving, right? So that direction is given by vector AB and the initial position is given by A. So I will call this OA as the location vector. This is location vector. Once I reach this location, I have to follow the direction, that along which direction I have to move, right? So that direction is given by AB. So I will call this as the direction vector. These position vector and direction vector are very important when we study the next topic, which is finding out the angle between two vectors equation of a line. Two lines have been given and we have to find out the angles, right? So this direction vector is very, very important. This you need to remember, right? Whatever the constant is multiplied by the vector, that is called the direction vector, and second vector is the location vector, right? So this is how you will derive the equation, or that is the meaning of vector equation of a straight line. Okay, in the next video we will solve a couple of questions based on this vector equation. Okay, see you.